This video is on ionic compounds, naming, and formulas. So there are three different types of ionic compounds that we can name. We can name ionic compounds that have metals in groups 1, 2, and 3. All other metals, and then ionic compounds that contain polyatomic ions. So an ionic compound is any compound where there is a metal and a nonmetal. Remember that on our periodic tables, metals are to the left and nonmetals are to the right of that zigzag dividing line. So we need to have one item from the left, one element from the right, and then they can give a transfer of electrons of one to the next to make an electrostatic interaction between the two of them, thus creating a new compound. So to name them, it's pretty easy. We take a name of the metal, and then we take the stem of the name of the nonmetal and add IDE. So for our NaCl, we look on the periodic table and we see that Na is sodium, so I write my metal name of sodium. And then I take the stem for my nonmetal, so my nonmetal is chlorine. So instead of INE, that's the ending, I just take my stem, which is the CHLOR, and I have chloride. So sodium chloride is the name of NaCl. If I want to go the other way and take a name and write a formula, well, my elements as ions, I'm going to look at the group number from the periodic table for groups 1, 2, and 3 only, and that's going to give me the charge of my metal. So if I'm in group 1, I have a charge of +1, group 2, +2, 3, +3, and for those. And that is the number, for nonmetals, the number of valence electrons to get to 8 is the charge of my nonmetal. So the number of valence electrons needed to get to 8 is the charge of the nonmetal. So my metal's charge is my group number. My nonmetal's charge is the number needed to get to 8. So if I'm in group 5, I need 3 more to get to 8, so my charge would be -3. Then I'm going to crisscross my charges down and only write the numbers, not the plus or minus, and then I reduce my subscripts. So for example, on the periodic table, I look for magnesium and then nitri, that came from nitrogen. So I have Mg, and then I also have nitrogen. I look on the periodic table to find magnesium, and I see that magnesium is in group 2. Step 1 here tells me that for an ion, for a metal in groups 1, 2, or 3, the group number gives the charge. So magnesium charge is +2 because metals lose electrons, so they become positive. Now nonmetals gain electrons and they become negative, and they gain the number of electrons needed to get to 8. So nitrogen is in group 5. It needs 3 more electrons to get to 8, so it has a charge of -3. I then take those charges and I crisscross down and I only write the numbers. So I take my 3 and bring it down, my 2 and bring it down, so I get Mg3N2. So my 3 and the 2 are subscripts, so that means that I have 3 magnesium atoms making electrostatic interactions with 2 nitrogen atoms to make magnesium nitride. For all other metals that are not in groups 1, 2, and 3, their charge can vary. So because their charge can vary, I'm going to use a Roman numeral to tell me the charge of my metal. So we need to use a Roman numeral because our charges vary. Okay. And to do that, we use that Roman numeral in parentheses. So remember, my Roman numerals are 1, 2, 3, 4, 5, and so on. You need to at least know the first 5. So in this case, I have vanadium and I have chlorine. So I look and I first need to take my charges and crisscross them back up. Well, there's no numbers written, so that means that my charges must have been 1 and 1. So I bring those up, and I check. What was chlorine's charge on the periodic table? Well, chlorine's charge on the periodic table is -1. So that means that vanadium's charge must have also been +1 because their charges cancel out. So that means that I must have had vanadium 1 chloride. So our nonmetal is still named the same way with the IDE ending on it. I still take my stem like before, and my metal is still the entire metal name. I just have added in my Roman numeral to tell me the charge. So going the other way, when I write my elements as ions from a name, I first need to look at my Roman numeral, because it gives the charge of the metal, and for my nonmetal, I look at the number of valence electrons that's needed to get to 8, and that's its charge. Then just like before, I crisscross my charges down, and I only write the numbers, no positive or negative. And then finally, I reduce my subscripts. So here I have iron 3, so that 3 applies to my iron, so I have Fe plus 3, and then oxide. So ox is my stem, and that comes from oxygen, so O. On the periodic table, I look, oxygen is in group 6. So that means that it needs 2 more electrons to get to 8. So it has a charge of -2. I take my charges, I crisscross down, and I get Fe2O3. They cannot be reduced, so that means I leave them just like that. The last type of ionic compound is with a metal and a polyatomic ion, or polyatomic ion and a nonmetal. So a polyatomic ion is just simply multiple atoms put together with a charge to create an ion. So it's a multiple atom ion. And we treat it like a unit. Okay. When we name these, we use different endings of ATE and ITE to help us differentiate the number of oxygens that are added onto our polyatomic ion. So most of the time, a polyatomic ion is where an oxygen has been bonded to one of our other nonmetals. Not always the case, but mostly. So if I look here, I have this pattern of oxygens from most oxygens to least oxygens with a polyatomic ion. So ClO3 is chlorate, the ATE ending. If I have one more oxygen than chlorate, with ClO4, I have perchlorate, keeping that ATE ending and adding the per on the front. Going back to chlorate, if I have one less, I go from 8 to ite, so chlorite. And then one less than that is hypochlorite. So that has the prefix and the ending. So just something to be aware of, the number of oxygens can dictate my ending. We can also note that acetate can be written in 2 ways. Most of the time, C2H3O2 with a -1, or it could be written CH3COO with a -1. Now I talk about that they're treated like a unit. So when we put them into our chemical equations, there are parentheses around the atoms of it. So there'd be a parentheses here and here. This way, if we have 2 acetates, we would put a 2 after it, and that shows that we have 2 of this entire thing. Otherwise, if we were to not use one, we'd have C2H3O2 and 2, and that would look like we had 22 oxygens when that's not the case. We have 2 acetate ions. So something to be aware of as we're going through, and we'll look more at this, and you'll see this more in class. But if you look down to the bottom here on how to name them, if we name them here, we say we have a metal name and then a polyatomic ion name. So here we see that we have 3 elements. So anytime we see that we have more than 2 elements, that means that something must be a polyatomic ion. Also, we have the parentheses here. That also tells me that I have a polyatomic ion. So I name it just like before. I take my metal name, which was calcium, and then I look for my polyatomic ion on the chart. So you all have a chart with your polyatomic ions, and we look for OH. We also notice that there's a 1 down here, so it'll be under the column. It has a -1 charge. So I look for that OH, and OH is hydroxide, so hydrogen and oxygen bounded together. Okay. We can go the other way too, where we are given the name and we look for it. So let's do these 2 together. So NH4, I look on my reference guide and I see that NH4 is ammonium. And that is the name of my polyatomic ion. It's in my parentheses. And then my nonmetal is sulfur, and that becomes sulfide. Okay, so just like before. Then going the other direction, I have calcium. Calcium is a group 2 element, so I have a charge of +2. And acetate, C2H3O2, is a polyatomic ion, so I put parentheses around it, and it has a charge of -1. So now, just like before, I crisscross my charges down, the 1 all the way to the outside of my parentheses here, the 2 all the way outside my parentheses there. And that means that I have calcium, parenthesis, C2H3O2, 2. So I have 2 acetate ions, 2 of them, that have an electrostatic attraction to my 1 calcium ion.